How's it? Hang loose. Mongoose Max here. We're going to do a little different take on news. And this is news in astronomy. Because up in the cosmos, they detected something May 21st, 2019. So just last year. So I call this little presentation Holes in the Sky, because we're talking about black holes. But what if two black holes collided or got together? If ever the two shall meet. Now I'll take a little excursion mentally maybe, and you might even do this for real. Out there somewhere, looking at the night sky. Did you ever just think about that? I mean, go and do it once in a while, but the night sky, all the clear, crisp stars out there, it's just awe-inspiring, and it has such great depth and such a feeling to it, and it can just be very calming and awe-inspiring and take you away a little bit. So we look at the sky, we see stars, and there's little twinkling because of the atmospheric disturbance, and some of the red ones are supposed to be moving farther out, and blue ones are supposed to be coming in, and we hear astronomy facts and wonder about the cosmos, look for constellations, and it's just stargazing is so wonderful. But we do know that there's black holes out there. Sometimes we don't think about them, but there's black holes. And how are black holes made? Most of the time it's basically an implosion. The amount of burning that the sun or star does expands it. It's expanding. It's expanding like a constant explosion outward with its consuming fire of this reaction that's happening. But it also has a massive amount of weight. And that massive amount of weight in the star kind of accumulates into its center. After things get burnt out, it starts going into the center. Larger things are made, it starts sinking to the center. And after a while, there's a lack of energy or lack of consumption, so it can expand or something, and then all of a sudden it runs out of enough energy to expand, and the gravitational force of its own weight implodes it. So it implodes and explodes at the same time, and you have a black hole is born. Our sun that we see every day is usually a little too small to actually make a black hole. It just isn't big enough. And our sun is also in astronomy used as a yardstick. Basically, one of our sun is equal to a solar mass. So our sun is that big. That's one unit, one solar mass. And there's a reason why astrologers do that. There are supermassive black holes in the universe that are bigger than basically we can wrap our minds around. Now, we don't see light, of course, because the light goes in and doesn't come out. And mass of planets, stars, will get close enough. The gravity is so dense and so strong, it's so compact, it has such a high gravity that it pulls it in, it sucks it all in, and this material strings out into atoms and like spaghettifies, they say. It just gets pulled in and it gets consumed. It goes in and it doesn't come out. It adds to the collective mass of the black hole, yes, but it doesn't come out. Neither does light. on this little circular horizon. So it's like the spherical shell of the black hole. It's the event horizon. And that point, no light comes out. Inside the event horizon, no astronomer knows. It's still a speculative unknown. Someone like Stephen Hawking will say the matter going in is information, and it's got to go somewhere, and there's speculation, but basically nobody knows. But sometimes it will, if it's consuming something really huge, it emits gamma rays. It's like a big belch of energy. And gamma rays can be very, very intense and destroy everything in their path. So we're lucky we're not too close to things called gamma ray bursts. That would be something of a bad day for the black hole and anything in its path or nearby. But usually what's radiated out is X-rays. On a good day, basically astronomers are looking at X-rays, not light rays. Even though they're both electromagnetic radiation, we're looking at X-rays for the cosmos exploration. So what is at the center of our galaxy? Well, it's mostly understood nowadays. It's very kind of a recent understanding. But at the center of every galaxy is a supermassive black hole. Supermassive black hole. And it's basically at the center of any galaxy, including our own. So these are born light seeds. Now, this could have a double meaning, but when it comes to supermassive black holes, 100 times the size of our sun is basically lightweight. So I'm thinking light is an amount of matter and amount of gravitational force pulling in. And they can grow to 10,000 to 100,000 times the size of our sun. Do they stabilize the galaxy? Do they have a purpose? Why are they there? Why is a supermassive black hole at the center of our galaxy? Right now, all we know is that that's what we understand is happening. So, where did they form? Where did they create? These are all huge questions. Now let me introduce you to the Chandra Deep Field South, or CDFS. Chandra is a deep space X-ray telescope. So it sees deep, millions upon millions of light years away, deep space. It observes X-rays, and this field is pointed south in a certain area or field. Look familiar? That's right. I didn't show you a picture of stars. This is an image of Chandra's deep field south, or an area of the sky that's so far away. This is an X-ray photograph, image. So it's an X-ray. It would be incorrect to call it a photograph, but it's an X-ray image, layered upon layered, to get the image, because it's so distant, it's that faint. Now, this area or field would be about 2/3 the size of a full moon in the night sky. And what's depicted here in this are black holes. A matter of fact, 5,000 supermassive black holes. Now, if you looked into the night sky or into the sky itself during the day, we simply can't see past our sunlit atmosphere, and we'll see blue sky only, but it's the same in the night sky as the day sky. 5,000 in this field, but in the total sky, about a billion. 1 billion, approximately, black holes. Supermassive black holes. So anytime you look up, even during the day, there's a billion supermassive black holes looking back at you. There's supermassive, and then there's the other black holes, which are called stellar black holes, off of the star. So a star is big enough, it implodes, it creates a black hole. It's a stellar black hole, and that's what we normally think of as black hole. And the super black hole is a little more recent addition to our understanding of the cosmos. What about the intermediate black holes, medium-sized? Well, yes, they exist. They're the range of 100 to 1,000 solar masses, or 1,000 times the size of our sun. And they're known to exist. They don't know about their formation. Did they exist before? Did they exist at the Big Bang? Because they figure these supermassive black holes cluster burst into formation early on during the Big Bang area. They weren't there because they were made. They formed from the Big Bang time area. The stellar black holes, you could say, are made when the star implodes. But what about the intermediate black holes? Where is their place in that? We know that they permanently suck in matter. So black holes sucking in matter, which it would be called information in the Stephen Hawking genre of all of his works. You got to dig into there why Stephen Hawking calls matter information. But they just pull in all the matter, so we know black holes can grow. But did these ones grow? Were they there from the Big Bang? Because the Big Bang was 13.8 billion years ago. Billion years ago. So, where does that bring us? Well, just last year, our news story. Welcome to 2 black holes. Both of them, large, but not that large, but large. And they collided. I guess they got on a cosmic play date, and when they hit together, they merged. Now, one of them was 85 solar masses, so 85 times the size of the sun, and the other one was 66 solar masses. So they both collided and meshed together, but when they collided, there was a bit of an explosion. And the end result was 142 solar mass sized black hole, an intermediate black hole for 100. But you might say, hey, August Max, that math, quick calculation, doesn't add up. It doesn't. Because if you took those two, 85 and 66, and added them together, it'd be 151 solar masses. So you only get 142 solar masses. So the difference is 9 solar masses. Well, what happened to 9 solar masses? That's 9 of our suns. 9. Where did that go? Well, that was the energy expended with the explosion. So when these two got together and merged, the resulting energy expended would be like 9 of our suns exploding all at once. That is a big boom. Now over here, it sends out what called a gravity wave. Now, a gravity wave is much different than a wave on the water, because water has water for the wave to go through. Sound has air for it to travel through. Well, outer space is somewhat of a vacuum. How does a wave go through a vacuum? Well, Einstein already told us. He theorized on it, and actually not too long ago, maybe about 9 years ago, LIDO, a type of large detector on Earth, very, very large, much like the solar, or those electron accelerator size, but LIDO was able to detect very minute waves in the gravity. Well, what does that mean? Well, in space, there's space and time, and you can think of it as a big netting, or a big graph, sheet of graph paper. You could think of it that way, just to represent it. And whenever something of mass is in it, it distorts the space-time continuum. So there's a dent in the space-time continuum every time there's a large enough piece of matter. And that indentation is a gravity. It's a measure of the gravity field. Well, Einstein already figured this. If you have a large enough, there's two black holes spinning around with axis and a rotational spin and an axial spin, and they're rotationally spinning around. They're already highly gravitational. So this is like a gravitational tsunami, you could say. And as they're spinning around, it's like waves in a pond. They're creating little gravity waves, and they can detect these. Gravity is being warped, and it's sent out that way. It's just mind-boggling. So, when these two got together and that wave happened of 9 suns, it was 7 billion years to Earth, because it was 7 billion light years away. So when they detected something, it was already 7 billion years old. They saw something that happened 7 billion years ago. That's half the age of our known universe. 13.8. Half the age of the universe ago. And what did they detect? Well, it was 4 wiggles around 1/10 of a second in the LIDO. So that's what they detected. But it was enough to indicate something 7 billion light years away. That's how the faint that we had, that they were able to detect on the LIDO. Now, our Milky Way galaxy, do we have a super black hole? Well, supermassive black hole centers are in every galaxy. There are about 100,000 multiple solar masses to about 1 billion or 2 billion solar masses, 3 billion solar masses. And our Milky Way supermassive black hole is 4 million solar masses. So, phew, that's a load off my mind. It's only 4 million times the size of the sun, and it's a black hole. So, when you get out there and take a look up into the starry sky and take in all that starshine and Have a nice, quiet, wonderful, profound moment to yourself. Remember, there are about 1 billion supermassive black holes looking back at you. Something to be inspired by. Anyways, y'all have a great day and or night, and as always, hang loose and aloha.